We're still in Chapter 11, Section 3, and we're looking at Goal 4. And in your notes, this should have a notation at the top that this is 11.3b. Okay, so we're looking at 11.3b. So yesterday, you learned that if you have a nonlinear function, in order to calculate the slope of a function f at point x, f of x, we find the slope of the tangent line at the point x, f of x. Hopefully you completed your homework that corresponded to that, so you've practiced on finding that slope. To take us into today's lesson, that derived function that you found is called the derivative. And it's the derivative of the function at the point x. It is denoted by f apostrophe x. Of course, we don't read that f apostrophe x, but it's read f prime of x. So the derivative is another word for the slope of the tangent line at a point. Derivative is another word for the slope of the tangent line at a point x, f of x. So the definition of a derivative. The derivative of f at x is given by, or f prime of x, remember that is our new notation to notate derivative. That's nothing more than the slope of the tangent line. And recall from yesterday, we learned in order to calculate the slope of the tangent line, we have to calculate the limit as h approaches 0 of f of x plus h minus f of x, remember that represents in your slope y2 minus y1, divided by h, and remember h represents x2 minus x1. Okay, so as you go through Goal 4 in your notes, it is very important that you always pause the screencast and try to find the derivative on your own. Once you've found the derivative, then turn it back on. So if I were with you in class today, I would not be working these examples in the front of the classroom. You and your partner would be working these examples in Goal 4 together, and then I would walk around the room, answer questions, and give you support where you need it. So please do not just watch me work these problems, okay? You pause the screencast, you work them. You turn it back on and you check your answer. If your answer is correct, then move on to the next example and fast forward to the second example or the third example. But if your answer is not correct, then take the time to watch me work through it, okay? So now's the time where you pause the screencast for example 1, remembering that when it asks for a derivative, it's asking for nothing more than the slope of the tangent line found by using our formula for a tangent line. So go ahead, pause, complete number 1, and come back when you're ready to check. So the derivative of f of x is 3. So if you got that correct, you can move on to number 2. But if you did not, I'm going to discuss it now. So remember that the derivative is the slope of the tangent line. So I'm looking for the slope of this function. So the first thing I'm going to ask myself is what type of function do I have here? I know that 3x plus 1 is linear. So it would look like this. So here's my y-intercept of 1 and my slope of rise 3, right 1, or down 3, left 1. So here's what that linear function looks like. And I know that no matter where I am on this function, my slope is going to be the same at 0.1 or 0.2 or 0.3 or 0.4 or 0.5 and so on. Because this function is linear, the rise over run will always be 3 over 1, 3 over 1, 3 over 1, 3 over 1. So I don't even need a formula in order to find the slope of a linear function. However, if you didn't catch that this was linear, and if you used the formula, I'm going to fill it out now. If you were ready to move on to number 2, move on to number 2. So we would be finding the derivative as the limit of h approaches 0. All right, remember the first step tells me to replace x with x plus h. So 3 times x plus h plus 1 minus the second portion of my limit formula is to subtract the function 3x plus 1. Notice how I followed the minus with parentheses, so I remember to distribute the minus, all divided by an h. Okay, so let's go through and distribute. So that gives me in my numerator 3x plus 3h plus 1. And now I'll distribute the negative minus 3x minus 1, all divided by h. And I still have not taken the limit. And now if I continue to simplify, I notice that in the numerator I have like terms 3x and negative 3x, so those will reduce or cancel to 0. 1 and negative 1 will cancel to 0. And my remaining function is 3h divided by h. Finally, I've found a pair of factors that will cancel. And so I'm taking the limit as h approaches 0 of 3, and we know that the limit of a constant is that constant. So you can calculate the slope by looking at the coefficient of x because the equation is in the form y equals mx plus b, or you can use the formula. But I would encourage you to be more efficient and look at the slope of the linear function. All right, let's take a look at 2a. Remember, I want you to pause the screencast, try to find the derivative of 2a on your own, then turn it back on to check. Okay, so you can check and your derivative should be negative 2x. If you did not get negative 2x, I'm going to work that for you now. So I know my function f of x is equal to 1 minus x squared. So the derivative, I'm looking for the limit as h approaches 0 of, first remember I evaluate the function for f of x plus h. So 1 minus, in the place of x squared, I'll replace that with x plus h squared. And now we continue by subtracting the original function. Remember those parentheses, all divided by h. So in my numerator, I will square x plus h. So x plus h times x plus h is x squared plus 2xh plus h squared. Now I'll distribute the negative, so minus 1 plus x squared, all divided by h. Go back to the numerator and I need to distribute the negative, so I'd make this plus negative x squared, negative 2xh, negative h squared. And now it's time to start looking for common terms that will cancel one another out. The negative x squared and the positive x squared will cancel. The positive 1 and the negative 1 will cancel. And that's it. So I'm left with the limit is h approaches 0 of negative 2xh minus h squared all over h. Now, is it okay for me to go ahead and evaluate the limit? Is it okay to put 0 in the place of h? If I do that now, I'm going to end up with 0 minus 0 over 0. So we know that we have not yet canceled the common factor. So I notice that the numerator has a GCF of negative h, so I will factor that out. all divided by h. And finally, my h's will cancel. And now I've canceled that pair of common factors, so I can now evaluate the limit. So 2x plus 0, my derivative is, and don't forget about this negative like I almost did, my derivative is negative 2x. All right, so part B is something you'll definitely want to pay attention to. Notice that part B says, now find the equation of the tangent line at the point -2, -3. So I'm asking you to take the given function. I'm going to draw a sketch just so you have a visual of what we're looking for. So this is 1 minus x squared. So we know we have a vertical shift of 1 and then a vertical reflection. And it's asking for the equation of the tangent line at the point -2, -3. So we're looking for the equation of this red line that I'm drawing here. We know that this line, like all tangent lines, are linear. And linear equations are in the form y equals mx plus b. And I can use y equals mx plus b to find my equation, or I can use y minus y1 equals the slope times x minus x1. So in order to find the equation of this tangent line, I need two pieces of information. I need a point, which I have. The point is -2, -3. And I need a slope, which I almost have the slope. I know that the derivative is -2x. So the slope at -2, -3 is -2 times -2. I replace x with the x coordinate, so the slope is 4. So now that I have this information, I like to use the point slope formula to find my new equation. So the equation of the tangent line is y minus -3 equal to the slope times x minus -2. So we now have y plus 3 is equal to 4 times x plus 2, or y is equal to, remember to distribute the 4x plus 8, and then I'll need to subtract 3 from both sides. So my equation is y equals 4x plus 5. That's the equation of this line that is tangent to the function at the point -2, -3. What I'd like for you to do at this time is move on. What I'd like you to do at this time is to move on to example 3a, b, and c. And on your own, work to find the derivative or the slope of the line tangent to each of those. Then come back and check your work. I am not going to talk you through 3a, 3b, and 3c like I did on the others. I'll talk through them a little bit, but do come back and check your answers. This will be on a separate video. So my discussion of 3a, b, and c and number 4 will be on a separate video. Please try 3a, b, and c on your own before you look at the next video. Thank you.